Welcome to this Tech AV training program on the subject of electric motor maintenance. This and following video presentations deal with three-phase induction type motors. During this part of the program, we shall discuss typical motors, their various parts and functions, and certain important facts concerning motor identification. Please ensure that you read your workbook to derive the full benefit from this course of instruction. Modern industrial operations are highly dependent upon electric motors to generate the power required to drive a multitude of machinery and plant equipment. One of the commonest motor types used today in industry is that which is referred to as a three-phase AC induction motor of the squirrel cage design. Let's take an in-depth look at such a motor type. The principal visible components are the stator frame, end shields, and the rotor shaft. Also visually apparent is the fan cover or cowl, the terminal box, and the motor nameplate. No matter what physical size the motor, and the sizes can vary considerably, the component names and their functions remain the same. For a more detailed look at the parts, let's look at a dismantled motor. In this situation, we can see that the rotor and its shaft are set in between a series of windings fixed inside the frame. This set of windings is called the stator. The stator is responsible for creating a magnetic influence known as a rotating field. In a three-phase motor, there are three separate windings within the stator. Each winding is created into a series of loops around a laminated metal core. Windings are terminated at the terminal board within the terminal box. It is usual to find 6 termination lugs or pins within the terminal box. The rotor plays an important role in the motor. The rotor and its shaft are responsible for the transmission of mechanical output. The rotor is supported on bearings, usually in the form of ball or roller bearings. Some motors, however, have plain or sleeved bearings, more common in the larger kilowatt ranges. End shields provide the means to support the rotor. The bearings are housed within the end shields. When secured to the frame, the end shields support the rotor in the correct position within the frame. Most motors incorporate a fan in order to provide cooling to the main motor parts. The fan is usually situated at the non-drive end of the motor and covered with a fan cowl. The other end, that is the exposed shaft end, is called the drive end. Attached to the stator housing is the terminal box. It is here that the supply cable is secured and terminated. The cover of the terminal box is removable for access to the terminal board, upon which the supply is connected to the phase end terminals. Some motors, however, may be internally wound in star or delta configuration. Such motors will then only have 3 terminal connection points. The terminal box cover will almost always be equipped with a gasket or special seal, depending upon motor duty classification. The incoming cable, upon an installation, is secured and sealed by way of a cable gland into the terminal box. The next feature we look at is the motor nameplate, and more than the word suggests, the nameplate reveals some important statistics about the motor. Much information displayed on the nameplate requires special explanation, so let's overview a typical situation. This nameplate reveals the fact that the motor is rated at 7,5 kilowatts. At a shaft speed of 1,450 revolutions per minute, designated by the letter N. At full load, the motor will draw 15,9 amps, operate at 380 volts in delta connection, on a supply frequency of 50 Hz. That's 50 cycles per second. We also see that it is a three-phase motor with Class F insulation. This refers to the temperature which the motor winding insulation can safely withstand, around 130 degrees Celsius in this case. Rating S1, another coded factor, refers to the fact that the motor is rated as continuous running at constant speed. Temperature 80 degrees Celsius is the degree of temperature above ambient at which the motor will run. This is referred to as the temperature rise. The letters and figures IP54 is the enclosure number, again an encoded number referring to the motor's ability to resist the ingression of harmful amounts of dust or water from rain or accidental hosepipe spray. The cosine theta stamping indicates the power factor and is information required by engineers to calculate the motor's power consumption. The remaining specification is the frame size. In this number D132M, one can establish that the shaft center is at 132 millimeters above the base line. The letter M designates a standard dimension between centers of the motor's pedestal mountings. As you've just seen, a lot of information is coded or symbolized on the nameplate. However, certain conventions or norms have been adapted to enable this information to be read by people all over the world. The purpose of a nameplate, however, is simply to enable us to be able to identify a motor or select a motor to do a job, or to replace a motor so that we know for sure that it will meet every specified condition. It is not within the scope of a video program to cover each and every motor type, class or rating. To do this, you require a comprehensive catalog from your motor dealers, which provides data for every specific customer or application requirement. It is suggested that you now stop the video and perform the exercises and tests provided in the workbook accompanying this video. In subsequent programs, you will learn to perform more practical maintenance or repair operations on three-phase induction motors.